The bottom of a feed bin for a chicken house is conical. It is an inverted cone with a radius of 5 feet and a height of 10. What? Okay, I'm gonna draw this one again. I know I've drawn cones on the other ones and it didn't really help, but this time it's going to. So, being raised on a chicken farm, true story, I have had a lot of experience with big feed bins, and they are shaped like this. They're upside down. They pour the feed in. Actually, there's a cylinder on top of that, so that you can put a lot of feed in there and it funnels down. But the bottom of it is a cone, okay? And they told us that the radius is 5 and the height is 10. Okay, if you're thinking, I'm gonna come over here and put R equals 5 and H equals 10, you're thinking like I need to list my information, and that's a wonderful idea, but trust me on this, okay? I'm gonna go ahead and just jump right into why we don't. These are the dimensions of the container. They did not tell you how much chicken feed was in there. We don't know how full this is. So as we do this problem, we're going to be dealing with the feed, the food that the chickens eat. And it might not be 10 feet high and 5 feet in radius. It might be 5 feet high. And if it was 5 feet high, it would be 2.5 feet of radius because, let's start listing some things. The radius to height ratio is going to be 5 to 10, okay? The dimensions they gave you have to do with the container, but the actual quantity of chicken feed, and I'll draw it. Here's some food. It's green. It's moldy. Don't feed that to your chickens. The height of the feed in the chicken bin, the chicken feed bin, in this case that I drew, is not 10. But if the height is 10 and the radius is 5 of the container, then whatever this height is, the radius is half of that. The radius to height ratio is 5 to 10, or 1/2. Okay, let's keep reading. Taylor, the truck driver, I don't know why his name's Taylor, is pumping feed into the bin such that when the height of the feed is 4 feet, okay, stop right there. Let's list that. The height of the feed is 4 feet. The rate of change of the height is 1.2 feet per minute. At what rate is Taylor, the truck driver, pumping feed into the bin? When they ask that and they want to know about the quantity of something, they are really asking about volume. So at what rate is the volume changing? If I went to my dad as a child and I said, how much chicken feed did we get? He would give me volume. He would give me so many cubic feet or something like that, okay? So let's figure this out. We're going to be dealing with the volume of a cube. Volume, 1/3 pi r squared h. This is a wonderful way to avoid the product rule if they give you a relationship between radius and height. They did here, they did on a previous problem where they said radius equals height, and now they're saying there's a relationship where the radius to the height is 5 to 10, or 1/2, okay? They gave us height, they gave us the rate of change of height, so let's keep height and replace radius. That's what we've done in all the other problems too, but that's okay. Okay, if we cross multiplied, we would have 10r equals 5h, which would mean that, I'll bring it down here, solving for r gives me, divided by 10, 1/2 h. I'm going to call it h over 2. Okay? It's actually the same idea we had here, it's just worded a little bit differently. It was h over 2. So same process as before. So 1/3 pi h over 2 squared times h. Let's skip a couple steps this time. My denominators are 2 squared, which is 4, times 3, so it's 12, and pi in the numerator. H squared times h is h cubed. There we go, we're ready to go. Let's take the derivative. 3 pi over 12 is 1 pi over 4. And we will start plugging some numbers in. We don't know dV/dt. That's what they're asking us. They told us the height was 4, and the rate of change of the radius was 1.2. All right, let's keep going. I'm gonna type all this in the calculator. Actually, I'm not. Let's not. We can do this one in our head. Trust me on this. Trust me on this. I don't know why I said it twice, but trust me on this. We can do this one in our head if we don't multiply by pi. 4 cancels with one of these two 4s because it's squared, and that leaves me with 4. 4 times 1.2 is 4.8 pi. Done. We'll get a decimal in a minute. But it's a measurement of the rate of change of the volume, which is going to be cubic feet per minute. Fantastic. Let's get a decimal approximation. 4.8 pi. We could move our decimal if we didn't do that. 15.0080 actually, and we will put that final 0. Good that we're doing this. Oh, there I am. Hi. You can see the ceiling. You can see where I'm holding up the phone to record it. You can see all kinds of stuff. Anyway, let's look at the numbers instead. 15.0. The 6 rounds up the 9, which rounds up the 7. I know you know how to round, but we get this, but we always need 3 decimal places unless the answer is truncated. Meaning if I'm doing some little computation and my final answer, I'm making this up, don't type this. My final answer was this, I don't have to put 29.400 because my answer stopped. But in this case, I do need to put the 0, and it is indeed still cubic feet per minute.